Today, we have the honor of having Laura Jackson present in this AMOC webinar series. Laura is a senior scientist at the Hadley Centre in the Met Office, UK, working in the Atlantic Process team of the Ocean Climate Group. Her research has focused on understanding the AMOC, including research on variability, projections, influence of resolution, and understanding stability and risks of a collapse. She has collaborated with various UK RAPID projects and has recent collaborations with the OSNAP community. She has also recently been working with the ocean reanalysis community and understanding how ocean reanalysis represent dynamics, which has led to her leading this paper presented today. So with that, go ahead, Laura.
Okay, thank you, Jenny. The title of this talk is Mean State and Variability of the North Atlantic Circulation, Perspective from Ocean Reanalyses. And this is based on a paper that's published end of last year as part of the US AMOC virtual edition. I should say that this paper originated actually from the Reanalysis community rather than the AMOC community. So I previously published a paper which looked at the AMOC and our Met Office ocean reanalysis and ended up volunteering to organise this paper, which compares a number of different reanalyses. So this talk does differ from other talks in this series. That is, it's a comparison paper rather than a review, and it doesn't primarily focus on the AMOC. So the scope of this study, we examined the mean state and recent changes in the North Atlantic with global ocean reanalyses with the aim of answering some questions. So where is there agreement and disagreement? Can we learn what makes a reanalysis good at specific processes? Are there periods where we believe the reanalyses are informative? And in particular, we've looked at the period since 1993, which is when our satellite altimetry started, since that's when these reanalyses have been best constrained. So scientific themes, so we looked at the AMOC, that's the RAPID and OSNAP sections, gyres, convection regions, so mixed layer depth densities, so I'm not showing much of that today, ocean transports and water mass quantities, and at the bottom this is the reference for the paper. So as a bit of background, what is an ocean reanalysis? So it's a forced ocean model that assimilates various observational data sets. So there are advantages of reanalyses over observations alone. So they can infill regions where there's sparse data. They can give dynamic results that are difficult to measure. Advantages over forced models are basically stronger constraints by the observations. But there are disadvantages. If the observational constraint is weak, then the behaviour may just be what the model is doing. Assimilation can cause spurious effects if the model and the observations aren't in balance and you don't assimilate them in the right way. So we need to assess the processes in reanalyses to make sure that what they're doing is, and also compare with other products. So we are using 7 different reanalyses here, as a sort of a brief table. About half of our NEMO models basically have the NEMO ocean model, and you can see that there's a wide range of different resolutions. Most of the NEMO ones are 1/4 of a degree, or there's 1/12 of a degree, and then the other ones are nominally 1 degree. So most of them are forced with interim. There are a few exceptions. All the reanalyses assimilate data sets, such as sea surface temperatures, salinity profile, temperature data, sea ice extent. They don't all assimilate all of those observational types, though. And assimilation is mostly through increments to temperature and salinity. They look at where how the model is different from the observations, and then you can apply increments to sort of nudge it towards them. Analyses use 4D VAR, which uses a very different assimilation method, where instead of using increments of temperature and salinity, you modify surface fluxes, and parameters, for example, involved in mixing to essentially try and achieve better temperature and salinities in comparison with the observations. So as I said before, there's 6 NEMO models, one of which is called 12th degree. There's also Reanalysis, one Reanalysis, which is an outlier, that's NOR CPM. It's partly an outlier, it is coupled, although it is a Reanalysis. So yes, it basically coupled an atmosphere and ocean reanalysis together, but maybe more so in that it only assimilates anomalies, so it doesn't try to constrain the mean state. So look at some results. Looking at the AMOC, looking at the mean state of the AMOC. So all reanalyses have an overturning cell. However, in some this isn't coherent tubes. So generally they seem to be pretty coherent in, say, the subpolar gyre, but less so further south. Particularly if you look at glossy 5 here, which is our Reanalysis. It's fine north of 20 north, but near the equator there's this large values, and then it's too weak in the South Atlantic. And we believe we know why that is, and that's the way we're doing the assimilation. That's being corrected for future, hopefully. If we look at 26.5 north, we can compare the AMOC profiles with RAPID. That's what we're doing on the left-hand plot here. If you ignore the red one here, which is the NOR CPM, which isn't constraining the mean state, they all do pretty well at getting the magnitude of the AMOC. And some even manage to get the sort of pretty well the sort of the depth profile. If you look at 50 north, however, there's a much greater range of AMOC strengths and a much greater range of depths as well. Looking at the biotopic stream function, which is shown here. So the main thing to see from this, you can see if you look at the subtropical gyres rather, a number of these have very intense gyres near the western boundary. This is because they have intense Gulf Stream. And we think these are all the higher resolution models. And so they have more intense Gulf Stream and much more eddying occurring there. So we can look across these reanalyses. So I'm sure many of you know that in many studies, the AMOC is related to the density in the Labrador Sea, for example. So that's what this top left plot is showing, comparison the AMOC strength at 50 north with the Labrador Sea density in the 0 to 500 metre range. And you can see that there's a significant correlation there. So reanalyses with a more dense have a stronger AMOC. However, we have 2 observational estimates which give this big bar here. So it's quite difficult to use the observations to say how strong from this this relationship you might think the AMOC is. There's also a significant relationship if we look at the AMOC compared to the subpolar gyre strength. So reanalyses with a stronger AMOC have a weaker subpolar gyre strength, and that's a significant correlation. Comparing the AMOC at 50 and 26 north, however, there's no significant relationship there. So if we look at transports, again, you might want to ignore the Norwegian one, which isn't constraining the mean state. There's 2 things to pick out from this. So the top one's the heat transports, the bottom one's the freshwater transports. So if you look at around 26 north, there's a number of different observations there. Those are shown in the symbol. And you can see that apart from the NOR CPM, all the reanalyses are underestimating heat transport there. One other aspect to point out is that if you look at 40 North, all the reanalyses which are sort of bluey-green colours, so those are all the reanalyses which use NEMO, so they have stronger heat transports and freshwater transports around 40 North. And they also have a higher resolution and a more intense Gulf stream. And we think it's that this more intense Gulf stream is giving greater transports at this latitude. So we can look at, particularly at top 26 North, many studies and the observations as well show relationships between the AMOC at 26 North and the heat transport. And you can see that there's a good correlations across the ensemble. And this is, overturning and the total heat transport. But if you add the observations, which are these circles here, you can see they're offset from that relationship. So it's saying that the reanalyses are underestimating heat transport even when they get the AMOC right. And this is something that's also seen in forced and coupled models, this similar sort of bias. So moving on to variability, starting from the subtropical gyre, so that's I think 25 to 45 North. So starting from looking at the AMOC at 26.5 North, and I'm just looking at the anomalies of the time series, and I've got the ensemble mean and spread in the black and grey lines here of the AMOC anomalies, and then the thick black line is showing the rapid observations, and you can see quite a good agreement with the ensemble mean in terms of the variability. You can see sort of a weakening from around 2006, get sort of stronger weakening in 2010, and then the sort of intrand variability after that. But you do see this, it's not getting all of that dip in 2010. And actually, if you look at the Ekman, which is the blue line, it seems to be mainly just getting the Ekman. However, that's not true necessarily for all the individual reanalyses. So if we bottom plot in the left-hand column, that's showing the AMOC anomalies in 2010 from all the different reanalyses, and the big crosses are where that's statistically significant in the time series. So all the reanalyses are showing a dip in 2010, but most of those are not showing as a strong a dip as the observations, which are the black dot. So we can also look at the other feature of the rapid observations, is this weakening 2006 and 2013. And if you look at the different reanalyses, most of them actually show that's a significant weakening over that period, though many it's not as strong as the observations, which are again in the black dot. So we can then look prior to the observation starting, what do the reanalyses suggest? So it all seemed to suggest between 2001 that there was a weakening. So there's we all seem to get after 2001, 2006 a strengthening of the AMOC. So this does seem to show some evidence for sort of multi-annual decadal variability of the AMOC. So these changes in the AMOC at 26 North are unsurprisingly seen in the transports of heat. So these time series here, you can see that the weakening and the big dip in 2010. This weakening trend is strongly related to the trend in the AMOC, and you can see that across the different reanalyses. And this relationship seems to agree with the relationship in the observations as well. If we look at the temperatures and salinities in the subtropical Gyre regions, that's 25 to 45 North, we see the gradual warming and salinification of the Gyre. And as well as some interannual variability. In particular, you can see this big dip after 2010, which is believed to be related to this very weak heat transport in 2010. You also notice that the salinity is much less constrained than the temperatures. That's the subtropical gyre. Now we can move on to the subpolar gyre. AMOC anomalies here show a quite consistent interannuality. Yes, interannual, multi-annual. If you plot the Ekman, that's the blue line over the top, you can see that corresponds very well with that, those interannual changes. So that's obviously a key component of the variability. If you subtract the Ekman from the ensemble average, that's the red line. And so now you see the ensemble is gradually over this time period. This is consistent with other studies, particularly using force models, which showed the AMOC strengthening up to mid-90s and then weakening over the period to sort of 2009-10. And this is believed to be changes in the NAO. So we can look now at all the individual reanalyses in the same way. We look at the trends from 93 to 2009 in all the different reanalyses. Most of the reanalyses are showing a significant weakening trend. There are a few are not showing significant trend. Most of them are showing significant weakening trend. Over the whole time period of this to 2016, there's no consensus on the trend, no trend over that period. We did look briefly at the OSNAP section in a few reanalyses. The OSNAP section is at around 55 now and measures the AMOC in density space. It's been going for, well, we've got observations here anyway for the paper for about 2 years. And that's shown this black line here. And these are monthly values. So you can see the reanalyses actually do a surprisingly good job at picking this, this dip at the end of 2014 and then strengthening and then weakening again. We think this is possibly partly the seasonal cycle and or local wind forcing, which is why all the reanalyses get that quite well. If you look at the interannual decadal variability, which is the top plot, actually there's quite a lot of difference on that, so there's little agreement. So then moving on to the gyre, so the subpolar gyre is negative. So when we see this sort of positive trend in the ensemble, that's basically weakening. And if you look at from 93 to 2009, you can see that most of them are showing a significant weakening of the gyre, which is again in agreement with other studies and observations. But then if you look at the whole time period, 93 to 2016, actually there's no significant trend, no consensus on trend over that time period. So we've got a number of different quantities in the subpolar gyre we see trends from over the 93 to 2009 period. So there's the Labrador Sea density, which I haven't shown. There's also the subpolar gyre and the AMOC at 50 north. So we can ask, are these trends related in any way across the ensemble? And the answer to that is basically no. So many of the reanalyses have significant trends in these quantities, but those relationships are different between the different reanalyses. So yeah, which suggests that there's a model dependence of the relationship. So we can also then look at the heat and freshwater transports at 50 north, and like the AMOC and the subpolar gyre, these all both these are all showing quite strong trends, strong weakening trends as well. However, when we did similar scatter plots comparing the trends in the transport to the trends in the AMOC and the subpolar gyre, we didn't see any relationships there. And that's possibly because the way they're interacting is different in different reanalyses. So then finally looking at the water mass properties, the temperatures and salinities in the upper subpolar gyre. Unlike the subtropical gyre, it's much more of a decadal signal. So we get gradual warming and acidification, and then cooling. So warming and freshening, and then all the way around. Warming and solidification, and then the cooling and freshening. This is consistent with the idea of having stronger transports at the beginning of that time period and weaker transports at the end of the time period. Though it is important to note that there have been changes from surface fluxes, which may well have also had an impact. So conclusions. So we find that the reanalysis shows some consistency. In particular, we see a weakening of the subpolar gyre in the AMOC 50 North from the mid-90s to at least 2009. And we should note that in previous studies, this has been related to changes in the NAO. A strengthening and then weakening of the AMOC at 26 North since 2000. And we've seen impacts of this circulation changes on the transports. And I should say in conclusion, so I think the analyses are promising tools to examine the recent climate variability alongside free-running ocean models, which can experience biases, and the observations, which are temporally and spatially sparse. Thank you.
Thank you, Laura. So if you have any questions for her, use the raise your hand button, or you can type your question into the chat box. I see one question from Lacey. I don't see your name fully on there, but if you can unmute yourself, go ahead and ask your question.
Okay, this is Achieve. Laura, that's a very nice talk. My question is, although in this paper you focus on reanalysis, I'm just wondering the relationship between 26° north and 50° north of the AMOC. For the free-run fully coupled model, do we see any relationship, or it seems as the reanalysis they don't have any consistent or coherent relationship?
I'm sorry, I think the sound quality was, I couldn't really make out what you were saying. The sound quality was quite bad. I think you're speaking about relationships between the AMOC at 26 and 50 north. Is that right? That's
right, yes. I'm wondering if the fully coupled model, whether they have any relationship.
I mean, I think it's difficult. I mean, it's difficult to tell in these reanalyses. So we don't see any obvious relationship in the strength across the analyses. Within an individual reanalysis, you might expect there to be some relationship, or for example, decay. However, we don't have long enough. I mean, the runs are only, I think it's 2014, 5 years. So it's not really long enough to see that.
Okay, thank you.
Another question. Your name appears as W large. If you want.
Yeah, that's me. Can you hear me?
Yep, we can hear you.
Yep.
Yeah, Laura, my impression is that it's the spread of the various reanalyses. I mean, each one is giving its best estimate of what's going on, and yet there's quite a huge spread, and that spread doesn't seem to have changed over the last 10 years, even though the models have changed. So what's your thinking of the real reason behind all that spread from reanalysis to reanalysis? And why isn't it getting better?
Do you mean in terms of with the increase in observations? Or?
Almost, no, model reanalysis to reanalysis. I mean, they're giving very different answers in some places, and that seems to have been the case for many years now. And yet they're the best each group can come up with. What do you really think is the underlying reason for the difference from one reanalysis to the other? And when you look at the fields, it's always there. So do you have any thoughts on what is fundamentally causing that spread?
That's a very difficult question. I don't think I can. I mean, I guess, within a reanalysis, you've got to balance, I guess, to get an ideal reanalysis, you have to have an ideal model and ideal assimilation system and preferably ideal observations. And I guess everyone comes at it from slightly different angles in terms of development and maybe what their priorities are in terms of improving. So maybe that's what it is, but yeah, I can't say, I'm afraid.
Okay.
We have a couple of questions in the chat box. We have one comment from Tony Rosati. It says, don't you think a non-stationary observing system makes it difficult to look at trends, particularly with Argo starting in 2003?
Yeah, is definitely true, and that is definitely a caveat on these, particularly on the trends. It's so certainly one reanalysis. There's a clear change in what happens as the observational system changes. It's not so obvious in others. I mean, I agree it's a question, and I guess the way to answer it is to perform some experiments where you take out some observations and see what happens. But I mean, the fact that the general picture agrees with say force models and other things is certainly encouraging.
Laura, can I make a comment?
Yeah.
I just want to actually comment. This is on the same topic with Bill Large's comment that we have spread, but the spread diminishes quite a bit during the Argo period.
Yeah.
Once we were able to constrain the system better because we didn't have such a sparse data set, then the reanalysis come much closer together.
Yeah, I mean, yeah, because when we started, I think it does depend on what you look at, as you say. I mean, certainly if you're looking at sort of deep properties, the Argo, I imagine, it makes a huge difference. If you're looking at heat content, for example, it makes a big difference, I think, in terms of the constraining.
All right, we have a question from Sergey. He asks, first says, thank you for the presentation. Let me scroll back up. What do you think are the ways of which you think reanalysis should improve given the available observational data?
Again, another good question. So I'm not somebody who runs reanalyses, so it may be better to ask somebody else this question. I mean, I think making sure that you test, because a lot of reanalyses are developed for particular purposes, like for initializing models, for initializing, say, coupled models, or for sort of seasonal forecasts and that sort of thing. And so I think maybe taking a broader look and seeing how different processes work in your reanalysis, and sometimes you come across things which make it clear. Like for us, when we plotted the AMOC full stream function, we could see that there was something going on at the equator, which we needed to sort out. But in general, I don't know is the answer.
Okay, another question. I'm sorry if I mispronounced her name. Question from, is it Devanarayana Rao? He asks, are these reanalysis open access publicly available? I know Echo and Aura 5 are open access.
Okay, so the data from our paper is, there's a link from our paper to a website where you can download, but that's only the sort of the time series and things that I've plotted here. So a number of the NEMO reanalyses are part of the Copernicus marine services, and the data is available to download from them. I don't know about all of them, all the other reanalyses, but yeah. So obviously Echo and is and the Glossy 5 or S5, the what's the other ones? And the Seaglaws resolutions and the Glories, both resolutions, are all available to download from the CMEMS website.
I think we'll take a few extra minutes to try to get through these questions. There is one from Bill Johns. He asks, since the models get the MOC about right at 26 north, do we understand why they all consistently underestimate the heat transport?
So we think, so part of the, I know from sort of other model studies, there's issues to do with how, to do with the thermocline, and also to do with getting the temperatures right in the boundary currents, I think. But I don't think anyone really knows exactly whether that's an issue of resolution or what. Yes, I mean, I guess the fact that the AMOC is generally too shallow might be playing a role as well.
A question from Sanki Lee. Quick question. Do you think that data assimilated reanalysis products are better than the surface forced model runs in reproducing the AMOC time series?
So from what I have seen, question, okay, yes. So in terms of the AMOC at 26 north, I haven't seen any surface force model runs. So they can get the Ekman dip, but I haven't seen anyone showing them getting the weakening trend at all. So that seems to suggest that the reanalyses are doing that, and we don't know. There's a big question as to why they're doing that. What is it that they're assimilating which is allowing them to do that? In terms of at 50 north, the force models all show this sort of weakening from the mid-90s, which is very similar to what we're seeing in the reanalysis products.
Gokhan did make a comment, for simulations get the weakening, I believe. A question from John Toll. Did your group attempt to quantify and compare AMOC and density coordinates rather than depth space?
So we looked across the OSNAP section, but only in a few reanalyses. So I appreciate that it's more complicated to calculate. We've got it in our reanalysis, but we didn't get everybody to calculate that.
And a question from Reanalyses Perez. Have you looked at whether there is a large spread in the reanalysis trends in the South Atlantic?
No, is the answer. So this paper was focusing on the North Atlantic, so we didn't look at the South Atlantic.
Okay, and then I know we have two audience questions still waiting. Shane, do you want to go ahead and ask your question? I don't hear you right now. See, Shane, are you there? All right, let's move on to Anish for now. Anish, you want to go ahead and ask your question?
Okay, sure. Can you hear me okay?
Yep, we can hear you.
Okay. Thanks for the very interesting presentation, Laura. So my question was regarding what observations have an impact on the AMOC representation in reanalysis? And is there an effort that evaluates which of these observations have the biggest impact in improving AMOC representation in reanalysis? Are there efforts to do OSSI-like experiments, observation sensitivity experiments, to evaluate the impact of observations on AMOC representation?
That's a very good question. It's something we definitely want to do. So in terms of the AMOC at 26 North, to try what happens if we remove certain observational types and things. So for example, leave out altimetry. Does that make a difference? We are a bit limited at the moment for logistical reasons. We can't. Our Reanalysis is extremely slow, so we can't actually do those experiments at the moment. We would like to in the future, or maybe another Reanalysis group or somebody else would like to do that, because I think it's definitely something which would be interesting to answer.
Okay, thanks.
Okay, great. Any final question for Laura before we wrap up today? Right, I don't see any movement in the chat box or in the raised hand, so I think we'll conclude for the webinar today. So thank you, Laura, for your presentation, and thank you for everyone for participating. We will take a break in August from the webinar series, but we'll reconvene on September 17th for a presentation by Amy Bauer. So I hope to see you all in September. Thank you.